How do you choose the right material using yield strength? Imagine building a bridge or designing a bicycle frame. How do you know the material you pick will hold up under pressure? That's where yield strength comes into play. It's a key property that tells us how much stress a material can handle before it starts to deform permanently. When selecting materials, understanding this number helps prevent failures and keeps things safe. First, you need to figure out the maximum stress your product will face during use. For example, if a bridge supports heavy trucks, the material must withstand that load. The chosen material's yield strength should be higher than this load, ideally with a safety margin. Safety factors usually range from 1.5 to 4 times the expected stress, depending on how critical the application is. For aircraft parts, you want a higher safety margin because failure can be catastrophic. For simple household items, a lower margin might be enough to keep costs down. Next, consider the type of stress involved. Materials react differently under tension, which pulls apart, and compression, which pushes together. Many materials have higher yield strength in compression. Knowing whether your part will be pulled or pushed helps you pick a material that can handle that specific stress. Stress concentrations are another factor. These are spots like holes or sharp corners where stress gets amplified, sometimes 3 to 5 times higher than the average. Even if the overall stress is below the material's yield strength, these hot spots can cause early failure. Designing smooth curves and adding fillets can reduce these stress points and make the material last longer. Environmental conditions also matter. Heat, moisture, chemicals, and UV light can weaken materials, lowering their effective yield strength by up to 50%. For example, heat can soften metals, making them easier to deform. Choosing materials that stay strong in the environment they will face or applying protective coatings can help maintain their strength over time. Manufacturing processes influence yield strength too. Heat treatments, forging, rolling, and surface finishing change the microstructure of the material, which affects how strong it is. Variations in production quality mean you should include safety margins to cover possible strength differences. Engineers often relying on standardized tensile tests to measure yield strength. These tests stretch a sample gradually until it deforms permanently. The point where the material yields is often defined using the 2% offset method, which gives a clear, consistent value. This data helps you compare materials reliably when making your choice. In summary, choosing the right material using yield strength involves knowing the maximum stress your product will face, adding a safety margin, considering the type of stress and environmental factors, and understanding how manufacturing affects strength. Using standardized test data ensures your decision is based on solid facts. When you understand these principles, you can select materials that won't deform or break unexpectedly, making your products safer and more durable.